Okay, so today we're going to talk about something called mean absolute deviation. Okay, now we started off a couple lessons ago with measures of center, and we talked more specifically about measures of center, and we used it to find what was called the measures of variability. Well, in some ways, this fits under the measures of variability lesson as well. Okay, the main focus on that lesson was talking about, we talked about box and whisker plots or box plots, and we talked about things like interquartile range. All right, today, and that was kind of more focused on using the median of the data. Today we're going to talk more about using the mean of the data and finding its measure of variability using the mean. All right, and that's what this actually is. The mean, it's called the mean absolute deviation. All right, so that's actually our only word today, or phrase, is mean absolute deviation. Everyone?
Mean absolute deviation.
So if you hear me say mad, I'm not angry with you, all right? And I'm not crazy, even though I am a little crazy, but that's not what it's talking about, right? So don't agree with me. All right, here we go. So your book says it's the average distance between each data value and the mean. The average distance between each data value and the mean. So here's what I have that it kind of actually, I think it's pretty precise in a way. It's the mean from the mean. Now, once we get done with this lesson, you'll kind of maybe wrap your mind around it a little better, and that probably make more sense. It's the mean from the mean. All right, here we go. Now, I want to give you guys a little heads up, a little warning. Okay. This lesson doesn't have very many problems, okay? But it is a problem that is extremely long. Each problem is very long, okay? So you need to be very careful. Now, I know a lot of us are looking for speed, but don't look for speed, because the worst thing you could do is just kind of go through this problem really quickly and make a minor mistake, and it would affect your final answer, which, of course, is not good news if you're spending 5 minutes on one problem. Okay? So, you need to make sure what my goal is with you guys today is I'm going to show you just one way to organize your data, and we record things that will help you out a little bit. Okay? So, let's go ahead and let me show you. Let's start with on page 449, problem number 1. All right, let's go ahead and read that problem. It says, the table shows the number of rose petals on several types of roses. Find the mean absolute deviation. Describe what the mean absolute
deviation
represents. Okay, so here we go. Okay, so kind of debating how I want to do this with you guys, because I've done it vertically and horizontally. So I'm going to do it vertically, just because usually when we deal with mean, that's a lot of times how we kind of stack our numbers. So the very first step is it shows in that we're going to go ahead and record vertically. We're going to record all of those data values, right? So 22 means 22 rose petals on that particular rose. The next one's 16. The next one's 35. The next one's 44. The next one is 17. Then 26, 33, 35, 20, and 52. Now, step 2, I'm not going to walk you through all this. Here's what I'm going to do. I'm just going to put, let's find the mean of this data. So, that means, of course, we add and we divide, right? So, this is definitely calculator kind of material here. 22 plus 16 plus 35 plus 44 plus 17 plus 26 plus 33 plus 35 plus 20 plus 52, and we end up with 300. And of course, I'm taking the 300 and dividing by 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, look at that. 9, 10. That's not a calculator problem. Our mean is, of course, 30. Okay, so here we go. Step 3. What we want to do is we have the mean. What we want to do is we want to find the distance between this and every single one of these. So what all we're doing here is we're subtracting by 30. Now don't worry, we're not talking about negatives, right? Because the distance from one thing to another is never going to be a negative distance, right? It's all about orientation. You can be on the left or on the right or whatever else, smaller, larger, but it's just the distance. So in this case, 22 minus 30 is negative 8, right? But it's the absolute value of negative 8. So it's just 8. So subtract 30 from each of these. And most of these can be mental math. If it's not mental math, you can use your calculator. Remember, they're all positive values. They're all just the absolute value because they're just talking about the distance. Now, mean absolute deviation is the average distance from each data value and the mean. We just found the distance between each data value and the mean. That's what we just found, right? There's your distance. Now we want to find the average of that distance. Okay? The mean from the mean. So we're taking these are all the distances that all of our data is from the average, from the mean. Now we'll go ahead and put step 4. Here's what we'll put. Mean number 2. All right, that just means we're finding the mean of all these numbers. So here we go. 8 plus 14 plus 5 plus 14 plus 13 plus 4 plus 3 plus 5 plus 10 plus 22 equals 98. And of course, we take the 98 and divide. The numbers don't change, right? We still have, in this data set, we still have 10 data values. So 98 divided by 10 gives us the final answer of 9.8. And so it says, describe what the mean absolute deviation represents. On this particular problem, we'll do step 5 and we're going to write our final answer. Here's all that they're asking you to do. Go ahead and start with the mean absolute deviation, which is important, 9.8. And I could just put something like the average distance between each, we'll call it data value, because that's what they called it in the definition. And of course, the mean of 30, right? The average distance between each data value and the mean and let's clarify the mean. We'll call the mean, remember, was the mean number of petals, because that's what we were talking about when we were talking about the mean, right? Kind of the average number of petals on all these roses were about 30. So the average distance between each data value and the mean number of petals is 9 8/10. So just kind of clarifying what that is. Restating it with the definition in a sentence form. So this lesson is focused on kind of how to calculate what it is, how to calculate it, and then next lesson we'll look in a little more detail about like how to analyze it, how to read it. What is it actually? What's the significance behind it? Okay. So right now we're just looking at how to organize your work. If you decide to do this all over the place, you will lose yourself in the problem. Okay. So please make sure you stay organized. Okay, questions? Okay. All right, the problem I want you guys to try is number 6. Number 6. Row 1, I have someone, just a heads up when I pass homework back to you, I have a no name, and I have another one that doesn't have a score, and I don't know if they're the same ones or different, so just when I get it back, let me know. Okay, just checking in. How many of you need more time on that problem? Okay. All right, checking in again. How many of you still need some more time on that problem? Okay, all right. Give you about another 30 seconds to a minute. Okay. All right. Go ahead. Turn to your neighbor. Not only, of course, tell them what the mean absolute deviation is, but explain to them, of course, share your sentence. All right. Go.
I got $7.48. Oh, it's gotta be minus 13.
All right, here we go. All right, so on this page, 449, it says the directions say find the mean and the mean absolute deviation of each set. And there's just a listing, and so it's just a quick description, a little more simplified than the one we did together a bit ago. It says cost of books in dollars, and then it just has a list, right? So here is, I showed you guys a vertical way of doing it. Let me go ahead. I'll do a horizontal way. All right, just to kind of introduce it to you. I don't care which way you do it, how you want to organize your work. You might find it easier than the other way. So here we go. So step one is I'm going to make my listing horizontally, pretty much just like it looks there. Cost of books in dollars. So $4, $15, $8, $4, $6, $11. A nice cheap book that's $1. $7, $3, and $1. Okay, and like we've talked about before, I might want to make sure I didn't miss any of my listings. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it looks pretty good. All right. So after that, right, step 2 says find the mean. Well, in this case, I'm going to find the mean. I'm going to record it. Sorry, I'm going to record it over on the side here. So 4 plus 15 plus 8 plus 4 plus 6 plus 11 plus 1 plus 7 plus 3 plus 1 equals 60. And how many did I say there were? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously, if that's the case, just for note purposes, right? 60 divided by 10. So our mean is 6. So then I'm going to go ahead and find the distance between 6 and all of these. So instead of going sideways like this, I'm going to go down. So subtract 6 here. It's only 2. Subtract 6 here. 9. Subtract 6. That's 2. Subtract 6 is 2. Subtract 6, 0. Subtract 6, and a little too fast, is 5. Subtract 6 is 5. Subtract 6 is 1. Subtract 6 is 3. Subtract 6 is 5. So there's the distances between all of our data values, along with the distance between that and the mean. And so now, remember, I'm finding the second mean, which is my mean absolute deviation. So here we go. I'm going to add these up. 2 plus 9 plus 2 plus 2 plus 0 plus 5 plus 5 plus 1 plus 3 plus 5 equals 34. And of course, still divide by 10, because that's how many numbers in my set, and I get 3 4/10. So considering that it says find the mean and the mean absolute deviation, my final answers would be 6 and then 3 4/10. It doesn't say to give an explanation or describe it or anything. Okay, questions? The funny thing is that I was looking at that and I was ready to put the units, and I look at the key in the book and they don't have units. But I would say that units would probably be the best. You're talking about books, especially considering that it's kind of a abbreviation of a word problem. So books would be a good one. Cost of books in dollars, yes. And then if you're going to do that right, $3.40. Okay, guys, questions? Like I said, we're going to move on and kind of show how to analyze this in our next lesson. Kind of what it actually means and how we use it. Any questions? All right, mean absolute deviation.